Alright, in this video I want to talk a bit about standard deviation. Standard deviation can help us with some things when looking at data. So when evaluating a data set, standard deviation can help us determine the spread of the data, right? So for example, let's see if on a number line like this, let's see if I represent my data values with dots. If your mean for your data is right here, this value right here is your mean, you would guess that most of your data would be near the mean, okay? So, but that could happen many different ways. You could have, let's use red dots and let's make them a little bigger. You could have some data values down here. And those red data values could give you this mean. Now, you could also have different data values give you that same mean. Maybe they visually look like this, right? So we would say that this data is more tightly packed. Okay, so we can represent this idea with what's called the standard deviation. So standard deviation we will define kind of to be the average distance from the mean. So if we say the standard deviation is 12.5 units, whatever it may be, then that's like saying that on average the data points are 12.5 units from the mean. So let me write that. For example, saying that standard deviation is 12.5 units, and that would have a context in it, and if you're looking at specific data values, okay? Saying that standard deviation is 12.5 units is equivalent to saying that each data value is an average of 12.5 units from the mean. So if we have a standard deviation of 2, then that data would be much more tightly packed than a standard deviation of 12.5, as long as the two data sets have the same mean. Okay, but so let's get into how to calculate the standard deviation. All right, and I'm going to do that using an Excel spreadsheet. In this Excel spreadsheet, I have basically some sample test scores here that I made up, so just so we have some data. Now, in real life, we will typically deal with many data values. Okay, and so these techniques really only apply to situations where you have numerous sample data. Okay, so the first thing we're going to do is, if I want to know on average how far each of these is from the mean, then why don't I go ahead and calculate my mean? And so the way to do that, you know how to calculate mean. You just add the data values and divide by the number of data values. So I'll do that down here. So mean, let's align that. So the mean will be the sum of these data values. You don't need to learn the Excel unless you just absolutely want to. The sum of those data values divided by the count of those data values, how many there are. Okay. So here is our mean for this sample data. Okay. Think of that as the middle of your data. Now, what I need to do is I need to then find out how far each of these data values deviates from this mean. What's the distance from the mean? So deviations from the mean. Let's go ahead and make all these cells wrap the data, wrap the text. There we go. So I'm going to equals, and I'm going to take the data value minus the mean. Okay? And then I'm going to use that same formula for the rest of these. So all I did was subtract my data value minus the mean to see how far my data values are from the mean. Now you can see some of these deviations are negative and some are positive. In mathematics, well, we want these to be positive, all of them. So there's a couple ways to do that, but mathematically speaking, squaring them is a very easy way to make these positive. So I'll call this next column the square deviations. Okay? So I'm simply going to multiply each number by itself. And then I'll copy that formula as well. So now I've squared my deviations to make them positive. Now that means at some point we will have to unsquare these because now the distances are too big, my deviations are too big. Okay? But the first thing I want to do is I want to average these square deviations. Because remember, my goal is to get my average deviation, my standard deviation, okay? Now this is the tricky part. And I can't really go into the theory in this level of mathematics, but the idea is typically when you average, you add these up and divide by the total number. However, when you calculate standard deviation, if you were to do that in a large data set that's a sample of a larger population, for example, taking these as my test score representatives from one class of an entire college of classes, this is just a sample data set. If you do that and divide by the total number, your standard deviation is actually not going to match very well with your actual standard deviation. That can be seen in theoretical statistics. So here's how you actually do it. This is the tricky part, and I'll make a note of this later. But I still want to add these numbers. I'm adding all my square deviations. But now I'm going to divide by the number of values, so I'll count them again, which I could just manually count them and type that number in if I wanted to. All of this could be done by hand. But I'm going to divide by one less than the number of data values. So I'm going to divide by that number minus 1. Okay, so in this case we have, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Instead of dividing by 12 here, I'm actually dividing by 11. And that's my average square deviation, is 299.9697. Now, that's my average square deviation. I actually want to know my standard deviation. So this is the point where I will unsquare that number to get my standard deviation. So I do that by square rooting that number. So my standard deviation in this example is about 17.3. On average, my test scores are 17.3 units from this mean of 77.83. Let's take this and put it back into OneNote where I can make some notes on it for you. Okay, so here is the same data set that we saw before. And so let's summarize this process one more time. So to get my deviations, deviation is another word for difference or subtract. Okay, so I subtract the mean to find my distances. But some of these are negative, so I then square to make them positive. Then I calculate the average of these, but I divide by one less than the total. And finally, because I squared my deviations, I have to unsquare to turn it back into a distance. Okay? And hopefully you got a kind of a feel for how to do this in Excel too, if you want to do it more quickly than by hand and more accurately. So to summarize the process for calculating standard deviation, you find the mean, then you calculate distances from the mean, or deviations, then you square them to make them positive, then you average the squares, of course dividing by one less, and finally you unsquare to turn it back into a regular distance. So that is what standard deviation is. It's how far on average your data is from the mean. And it does have another term as well. Sometimes it's called dispersion. They both mean the same thing, and they're both calculated the same way. So that is standard deviation.